In this video, I'm going to give a taste of how you might use Fusion 360 CAD software to build a parametrically linked 3D model of a bike frame. There's way too much for me to go over in this video if I was going to explain everything, but if you watch the whole thing, you probably get a sense of some of the stuff you can do with this software, how you might go about some of the particulars. Hopefully it'll inspire people to roll up their sleeves and figure out this software, or to learn something new if you're already a little bit familiar. So let's get right into it here. I have a new file opened up, and I made a new component and I saved it. It's called Parametric Bike Demo. And now that we have this, I want to go into the parameters dialog. And so you can pull that from the modify menu, change parameters. I have it saved on the top here. It's the FX logo, function logo. And so I named some parameters. We have bottom bracket height, seat tube angle, head tube angle, top tube center to center, seat tube center to top. These are like for a traditional road bike. I just kind of have more of those frame geometry numbers memorized in my head. So it makes it a little bit easier to do a demo. And these are some of the very basics that I want to be able to edit later easily. So I click OK, and now I'm going to create a sketch. And if I click create sketch and I look at this view cube here, I want the front of it facing to the right, and I want to draw it on the left side, sort of like we're used to seeing bikes with the drive side facing toward us. So I'm going to click on this plane. That's what that little blue box was. And I'll hit L for line. It's the line tool. First, I'm going to draw a level line at the bottom. I'm going to click that line. I'm going to press the X key. That turns it into sketch geometry. And I'm going to do a D for dimension. And this is going to be bottom bracket height, because that's the ground is the line, and that point is my bottom bracket shell. Now I'm going to do another line. This will be the seat tube. I'm going to click that line. I'm going to press D for dimension, and I'm going to dimension it seat tube center to top. I'm going to do another dimension. So whenever I want to dimension anything, I just press the D key, and then I click the things I want to dimension. If you click two lines, it understands that you want to describe the angular relationship between them, generally, unless they're already constrained and they're parallel. And so I'm going to type in seat tube angle, and because I already made that list of parameters, I can just type these things in, rather than normally you would click in somewhere and you would type a number of degrees or a number of millimeters when you're dimensioning it or whatever. If you use parametrics, then somewhere else in a convenient single location, you can have a list of named parameters, and you can go back and edit those. And so that'll become powerful in a minute here. This is our down tube. We'll do another line for our top tube. We'll do another line for our head tube. And now these don't need to have exactly the correct relationship, because we're going to use these things called constraints to put them together how they need to be. So if I click the end of the top tube and I click the head tube, those become coincident. I use the coincident constraint relationship. So now this line ends on the other line. And if it's not even connected anymore, then it'll at least end along the axis of that line. So that helps us. Now I'm going to extend this ground line. D for dimension. I'm going to set the head tube angle. Oh, I spelled it wrong. Heat tube angle was the name of my parameter. Then we're going to have, I want the top tube to be level because it's a classic road bike. So if you click on something and then you click this one, this is the horizontal vertical constraint, makes it level or vertical, whichever it's closer to being. And then not everything in this model needs to be in that parametric list of parameters. I'm not going to bother with that for every single thing. This is my top tube, and before I dimension it for length, I want to constrain it in some other ways, because sometimes when you go to dimension things, things just go flying way off the screen. It's a little bit obnoxious. I'm not sure always the best way to deal with that, but not every dimension needs to be saved in my parametric menu. I don't want to have 1,000 little detailed dimensions in there, cluttering it up. I want to have the ones that are most central to how I might redesign this frame. So I'll say that this is 40 millimeters. I can always go back to this sketch later and change these individual things. What I want is that one parameters menu to have the most critical things listed handy for me. This is the top tube length. So now here we have the down tube. I don't want to define the down tube angle. The down tube angle is a driven dimension, really. It's based on some other things. I don't want to define the head tube length, at least not for this bottom location. That seems kind of irrelevant. And so I need to know how far up does this bottom of the head tube come. I'm not going to worry about that just yet. If I hit C for circle, I can draw a wheel. That'll be the rear wheel. This will be the front wheel. I'm going to use my tangent constraint to make these circles tangent with our ground line. Then we have, if I draw a line between the bottom bracket, so L for line tool, and I draw that line from the bottom bracket to the center of my rear wheel, that's basically my chainstays. So I can dimension that line. Things are starting to come together here. The diameter of this circle is wheel diameter. Same thing for the front. Unless you were making a funny bike, you would need to stipulate 2 different wheel diameters. You know, funny bike with like a smaller front wheel or something. And there's different ways that you could define where that front wheel sits. I'm going to build this like you'd build a classic sort of road bike. And so I'm going to lift up the bottom of the head tube here. Let's build like a fork. So the fork, basically, it has like a forward offset, which people call a rake. And then it has a section that comes up to the top. I'm going to make this section collinear with the head tube. And then going to do some sketch geometry here. This one here becomes the sort of fork rake, like the forward offset. So I want to make these construction geometry where they're just dotted lines. I want to give a perpendicular relationship between this line and this line so that they're square. I'm going to pause the sketch for a second. Yeah, finish sketch. Go back to change my parameters. Let's add some more here. I want to do fork, rake. Let's say it's 45 millimeters. Let's do another one. Fork length. 400 millimeters? I don't remember what that is usually. And so the distance, now I can dimension from this point to that point. Oh, I need to edit the sketch, right? Right click on, so down here in our history timeline, I got to click on the sketch, right click on it, edit sketch. Now I'm back into editing it. And when you go to dimension it, you can dimension it in all different ways. Am I going vertically or am I going along the length of these lines? I want to go along the length of these lines. Fork length. And then here, this is fork rake. And now the length of this line, I guess that's a little more theoretical. But this one here, this point up at the top is like our crown race seat. And there's all different ways to model a fork. I guess it depends on how you build it, how you want to think about it. I'm thinking about this a little bit more like when I would build a segmented fork that had straight legs that came back to a certain point. Maybe not everybody thinks about forks like this. We'll say this is 30 millimeters. See, that one I just dimensioned in here because I just don't think it's critical to be able to go back and edit that later. Whereas I do want to be able to quickly edit something like the fork rake. Now, if everything was contained in one sketch, you might just come back to that one sketch and make changes. But as you start to flesh it out, the 3D model, you're going to be storing these different variables in all different layers of sketches and in different 3D commands. And it's become a huge nightmare. You want to centralize all these numbers in one place. I'm going to do L for line. I'm going to draw a line between the hub of the rear up to the top of the seat tube somewhere here. And that's going to be my seat stays. And so I want to... the only thing that's not constrained about these right now is that end point. So I'll give that a dimension between the top of the seat tube and down. We'll say that this is 60 millimeters. So a lot of these dimensions are things you would see within BikeCAD, and they have their own parameters that you can adjust, which is pretty cool. And in this case, this is just one way to do it. But now that this is, if you look at it, you'll see that it's fully black and defined. So in Fusion, when you start sketching stuff, like if I hit the L for line tool and I draw a line, it shows up as this light blue color. And what that tells me is that it's not fully constrained. I can drag it around in space. I can change the length of it. I can change the angle of it. I can move each endpoint independently. And as I start to apply dimensions and constraints, it gets fewer degrees of freedom or whatever. And eventually you get it to where there's nowhere that it can go. Every characteristic of it is constrained by something. And there's rules that define its free motion. And so really, when you're sketching stuff, you would like to get everything fully black and defined. You would like to lock everything down before you leave it. If you didn't, that means that it's just sort of a drawing and stuff's kind of floating. And as you start to make changes, things can just move around on you and get weird. So that's my sketch, and let's finish that sketch. So now if we go into the change parameters menu, this is where it starts to get fun. If I want to change my bottom bracket height, I can click on this and let's make it 285. Well, now it adjusted. This is like an incredibly crude sort of BikeCAD, and it's starting to get a little bit fun here. You could change all sorts of things. The top tube is level right now, but I could go back in, delete that horizontal constraint that I applied to the top tube right there. If I delete that and then I dimension it between the top tube and the ground, it'll give me an angular relationship, and I could define that by a parameter. And now I would be able to, from my parameters menu, change the top tube angle, which is pretty cool, but I don't really need to do that. I don't really care to do that. So this is my bike here. And now I want to start turning this into a 3D solid model, which is kind of its own whole can of worms, and let's get into that. The first thing I want to do is I want to make the bottom bracket shell, and before I can do that, I want to real quick make another sketch. So if I click the create sketch icon up here, that'll allow me to do that. I'm going to click a different sketch plane this time. This is going to be on a perpendicular sketch plane, and so if I hit L for line, I'm going to draw a line here that goes through that same origin. I'm going to constrain that line with a horizontal constraint, and I'm also going to make it so that the midpoint of that line is on the origin. So if I drag the ends of the line, you'll see that it moves symmetric about that point. And I want to give it a length, so if I hit D, I can dimension it, and I made a parameter for bottom bracket width. So it's a 68 millimeters. It's an old school road bike bottom bracket shell. Now that we have that, and there's all different ways to do this. This is maybe not the best way to do it, but it's a way to illustrate it. It's a way that I kind of figured out so far. I want to use the pipe command from the create menu. So I click pipe, and I'm going to select this line, which is the bottom bracket. For the section size, I'm going to type in bottom bracket diameter, which is a parameter I created. And for section size, I'll type in a value here, 1.5 millimeters. So now we have something that looks like a bottom bracket shell. I'm going to move on, and I'm going to start doing some of the frame tubes. So I've made parameters for different tube diameters. And so if I right click here and I go up, I can repeat the last command, which is the pipe command. I'm going to click on this line here, and I am going to type in for section size again. I'll do STD, seat tube diameter. Section thickness, we'll say it's 0.9 millimeters. And let me just go back to this command actually. So you can always go back if you're saving your design history in Fusion. So if you right click on the top thing here, there's do not capture design history. That would turn it off. I want to keep it. If for some reason you're not recording design history down here, then the first thing you want to do when you open your program is to start capturing design history. I think the default is to capture it, but that's an important step so that you can go back in your timeline and change things. And I want to edit this pipe command. And so here we have the way that it works here is that I'm doing a join between this body, which is the bottom bracket shell and the seat tube. I could cut between them, and you see this red here is like the shape of the seat tube that it wants to create, but rather than creating it, it uses it as a tool to slice through the bottom bracket shell. So you can see how it would cut there. I could also do an intersect, which would leave only the areas that are intersecting. Or you could do a new body. That's another option. And I think I'm going to do a new body in this case. And so let's create it. If we on the left here, if we do the drop-down menu from our bike frame and we open up bodies, we have body 3, which is the bottom bracket shell, and body 4, which is the seat tube. Cool. You can name those if you want. So this is bottom bracket, seat tube. All right, so let's get on with it. Let's make some more. If I right-click and, oh, no. So now it would repeat rename. I don't want to rename anything. I want to do the pipe command. I thought if I right-clicked, the last thing was the pipe command. I guess not. So I'll click on this line. That's the top tube. Section size is TTD, top tube diameter. Section thickness 0.9. Sure, I don't want to join them. I want to make a new body. Okay. And there's a discussion to be had about whether you make a new body or a new component. That has implications depending on what you're trying to do. It's a little bit of a complicated question. I'm not going to get into it here. I'm not really an expert with it either. Again, right-click, repeat pipe, and down tube diameter. Now in that case, I didn't do what I wanted. Edit feature. That was a cut command. I want to do a new body again. I'm just going to keep doing new bodies. Then I'll do the head tube. Right click on this. Sorry, right click in space. Yeah, that won't work for me. Pipe command again. That's my head tube. Head tube diameter. Wall thickness is going to be 1 millimeter in this case. New body. And so now we're looking at the front triangle of the bike. If I go into my view options here and I click that little eyeball next to my first sketch, that gets rid of that sketch for the frame and kind of cleans up the look of things. So this is pretty cool. If I go into my parametric menu now, I have all the frame variables, but I also have the tube diameters, right? And so we're starting to collect more and more and more parameters and data. And whereas in this first initial sketch, sure, within one centralized sketch, I can change a lot of these parameters. Why would I bother putting those parameters and naming them and throwing them into a menu? The reason is that as you start to build a model and flesh it out and it gets more complicated, you have more layers. Now, the diameter of this tube isn't saved in that first sketch, it's saved in this pipe command. So if I have to come back into this pipe command to change the bottom bracket shell diameter and there's just more and more and more things, you'll have these numbers hidden in all different places. And so centralizing the data is really cool. Makes it a little bit more user-friendly, something like BikeCAD. So if you look inside the tubes, you're going to see this, it extends through there. That wouldn't physically really be possible. You would need to cut one tube or the other. And of course, in bike frame building, we usually miter the intersecting tube, and the continuous tube doesn't really get a cut, maybe a vent hole. Now, for visualization purposes, when you're looking at the outside, maybe that doesn't matter. But if you wanted to make that edit, here's how we would do that. There's a number of ways to do it. I'm going to use the modify menu, and I'm going to use the combine tool. And so my target body in this case will be, let's say, the down tube, and my tool body will be the head tube. What do I want to do? In this case, I do want to cut. So I want to use the head tube to cut the down tube, and you see how it gets rid of the intersection area, and then it slices the rest of the down tube into two pieces. And I'll say okay. So now it created that, although it consumed my head tube in the process. So let's edit that feature, keep tools. I want to keep the tool, which is the head tube. Okay, so now if we turn off, which one is the head tube? That's body 7. if we turn off visibility on that, what you'll see is that the down tube has this slice. Well, which body is this? This is, says BB1. So I'll just make that invisible is what I'll do. And then I'll turn the head tube back on. Turn the head tube off. Turn off visibility on that one piece. So this is what the mitered tube is going to look like. And again, you know, there's all different ways to skin a cat and to do this, but that's just one example of how you could use the sort of modeling engine to create the geometry of the tube. And now it doesn't protrude on the inside. We can do the same thing on the top tube. Modify, combine. Target body will be the top tube. Tool body will be the head tube. Keep tools. I want it to cut. Okay. And now if we click on this little remainder section of top tube, we can turn off of its visibility on the side menu here. It said it was body 5, so I'll just make that invisible. It's still there. That's one way to get it done. And so you can do that with all the remainders inside of the bottom bracket shell and whatever. All right, so moving on, we have the front half of the bike. That's all spiffy and cool. How do we do the rear end of the bike? I'll create some parameters right here. Chainstay diameter, we'll say that's 19 millimeters round. Do another one, seat stay diameter, 16 millimeters round. Okay, so if we turn on the visibility of our first sketch again, I drew these lines that in a two-dimensional drawing, this line sort of represents the chainstays and this line sort of represents the seat stays. And of course, it depends on how you build the bike, whether or not these tubes are straight in this sort of view or not. But this is one way that you can model a simple sort of bike. And so if I click on that, I can use that not, you know, it's in one dimension. We don't want to run a pipe command for a tube along the center. That's not what we want. But what I can do is in this drop-down menu for construct, I can create a plane based on that line. And so let's see here, create plane. So I can use the construct menu to create a plane at an angle. If I click on this line, you'll see that it creates this yellow thing here is a plane, like a two-dimensional construction plane. Over here on the origin, we started with these 3 planes for our three-dimensional work environment. And I just created a new plane, and we'll accept that. And so now that we have it, we can draw a sketch on that plane, and that's just what I'm going to do. This is going to be the seat stay or the chainstay sketch plane. So I'll click on that, and now we have, this is our bottom bracket shell, and this is our head tube, and this would be the rear end. So I'm going to draw a line right here, make it horizontal, make the midpoint, the end of our chain stays there, and dimension it. And this is going to be 135. Nope, it's going to be 130 because we're doing an old school road bike. And if I want, I can make a parameter for that. Let's not bother it right now. Then we'll do a line. And I'm going to do a line between, well, let's see here. Finish sketch. I'm going to turn that second sketch back on again. Yeah, there we go. That second sketch was our bottom bracket center line. This one is 2D frame sketch. This third one here is our chainstay plane sketch. Okay, so now I'm going to edit this chainstay plane sketch again. And I'm just going to do a real simple straight tube, L for line. I'm going to start it along that line of the dummy axle, and it's going to come down to this line of the bottom bracket shell, center line. Do the same thing on the other side. This isn't exactly representative of how I would build it on a bike, to be honest. This is a shorthand for illustration purposes. Hopefully you get the idea. So now I want to make the ends of this line coincident with our bottom bracket center line. I want to dimension from the end in, we'll say 12 millimeters. I could make a parameter again, but I'm not going to. Now here I could type 12 again, Or another cool trick is just click on a different dimension that already exists. And now this is sort of like a parametric thing without bothering to name it and set it up in the parameters menu. I could change it to 13. And this one here, it's a function of dimension 78, which, this one here is dimension 78. A really cool trick, even if you don't bother naming parameters in the parameter menu. You know what? I'll just reuse the same dimension here, D78. Whatever. I probably would want those to be independent variables, but in this case, they're close enough. Let's just call it the same. So, okay, this is just like a crude sort of representation of where I want those chainstay tubes to go. Again, there's more steps involved if you really want it to be a super fleshed out model. So I'll use the pipe command from the create menu, pipe, and I click that line, chainstay diameter, new body, okay. And now that consumed our sketch, so I want to make that sketch visible again. And if I right click, repeat pipe, okay. Zoom in, click on that. CSD, chainstay diameter. And I need to edit that because it did not do a new body. It did a cut. So I think I could set that as a default maybe, but it changes depending on what kind of stuff you're trying to build. So, okay, so now I have some crude chainstays. Again, these that's not really how you do chainstays. This is just sort of a simple mock-up to give you an idea. Same thing again. I'll build another construction plane at angle. I'm gonna click that line and click OK. New sketch. Click on that plane, and now we'll do a line again, and we'll go from that endpoint of the chainstays up to somewhere on this seat tube here. That's not really how they do seat stays on traditional road bikes, but this is all just to illustrate the principles at play. I'm going to make this point coincident with that point, this point coincident with that point. These have moved. I suppose they were never really tied to the seat tube, so there we go. And I would like to dimension. That's kind of a weird way to dimension that. Just trying to get it locked in so that I can continue to build the model. So now if I do the pipe command, and we'll click the drive side. Make that sketch visible again. Create pipe. Click that line. New body. Okay, so now I can turn off these sketches. And here we have something that looks even more like a cool bike frame. Again, sort of weird. The seat stays usually don't have this much overlap. That would be really frustrating to try and weld that, and it'd be pretty tight tire clearance back here. Seat stays and chain stays don't meet in this particular location. This is shorthand. You get the idea. You can get as specific as you want when you're sketching this stuff out. You can build very accurate, fully fleshed out models. But I want to show what you can do with this now. So we have this list of parameters, and this is where it gets kind of exciting. We have a bike frame, and I want to change the bottom bracket height to 280. Well, now everything adjusted. I want to change the top tube center to center length to 55 millimeters. See, it'll do something weird. BikeCAD does that too. It'll do whatever you want it to do, as long as the constraints don't collapse in on themselves when you go to make that change. If I change the fork rake, that's not even modeled, but it pushes the sketch around. So if we change it to 50, it makes a subtle difference to where the bottom of the head tube sits and some other things. Let's see here. Top tube diameter. Oh yeah, I thought I wanted the top tube to be 1 inch, but you know, through my iterative design process, I'm realizing these bikes are real noodly. Let's bump that up a little bit to 28.6 millimeters, and now it gets a little bit bigger, and you can see that, and it's in the 3D model. So Fusion 360 software, very cool, very accessible. This is just the tip of the iceberg, and for me to build a fully fleshed out model would take longer, and to explain it would take eternity. But hopefully this gets you inspired to dig around and start playing with it. Think about the potential in the rear end of the bike here, between the chain rings and the tire. That's a super duper pinch point. Just about every builder who's built anything with short chain stays or fat tires has wanted to pull their hair out trying to deal with that. Well, imagine, you know, chain rings sit at a particular distance off of the frame center line, and they're of a particular diameter. You can model those pretty easily. The tire is, if you use the, let's see here, in the create menu, the torus command, you can create something that looks sort of like a tire. Or, you know what, let's model a tire here real quick, just as an example. So if I do another sketch, let me turn on the construction plane. I want the seat stay plane, or the chain stay plane, and I'm going to do another sketch on it, and I'm going to turn off the bodies. Wait a minute. I guess I'll leave it on because I don't really know what's going on here. Okay, so the origin moved for this sketch. It's not in the same place anymore. That's kind of funny. Anyway, if I do a C for circle, and I'm drawing on this plane while I look at it from a different angle just so I can kind of see what the heck I'm doing. It's a real skinny tire, right? It's a classic road bike, 19 millimeter. God bless you if you're riding a 19 millimeter tire. The diameter, I want to define the diameter based on... we did the wheel diameter earlier, and so if I turn on the chainstay sketch plane, and now when you're dimensioning stuff, if I hit D for dimension, and I can dimension from that point to this point, but I don't want to do that. I want to dimension from like the outside, so I'll click pick arc/circle tangent. I click on that side of the circle, and then I click this point right there. And that number, I'm going to type in wheel diameter. I want that, but I want to divide it by 2 to give us the radius. And you can do that in Fusion in the dialog boxes where you're typing in values. You can do math equation statements. And now if I want to make it horizontal with that point, which I've done, and now it is fully black and defined. It's not going anywhere. That's pretty awesome. Finish sketch. And now, okay, so one of the very common things that you'll do when you're making a 2D sketch 3D is you'll use the revolve command. So I select my profile, which is this. There it is. It's the circle that is the tire. And I select my axis of revolution, which is the center line there. And, okay. I want a new body. That looks good to me. Or I could even do a new component in this case. That'll give me a tire. All right. So anyway, let's turn off that sketch again. And actually, let's turn on the first sketch. You'll see that because the outside diameter is based on the wheel diameter, it sits right on this line. And if I change the wheel diameter in our parameters, so where's the wheel diameter? 680. Let's change that to 685. We're still sitting pretty on the center line. Everything had updated around it. There's a long learning curve with CAD stuff like this, but when you start to figure it out, it really becomes very powerful what you can do with it. And so, you know, I just swept that profile around. You could do the same thing with a rim that gets swept around. Anyhow, I hope this video series inspires you to dig in and to get your hands dirty and to learn some new stuff, especially if you're stuck at home right now. This has been incredibly valuable for me to learn. how to 3D model stuff and how to solve problems by having the spatial awareness. It's really powerful because it helps you communicate with other people. So let's say you wanted to design a dropout and you could model it. Well, then you can send it to a machine shop and ask for an RFQ and say like, yeah, how much would it cost to get 30 of these made by next month? And they'll give you a price. And so when you can use this software, you can make better designs, you can make them more quickly, more easily, and you can communicate ideas with other people better. All those things are awesome, and I hope you feel empowered and inspired to download Fusion and give it a try.